Hi everyone, we are here to introduce our project Landslide Prediction and Early Warning System. Here is our team. We are from Electronics and Instrumentation Department FISAT. We all know that landslides are one of the deadliest disasters of all time. It is the downward movement of massive rocks, debris, or earth through a slope. Rainfall is the most common trigger of landslides around the world. Other main causes of landslides are changes in slope gradient, shocks or vibrations, alteration of water content, groundwater movement, etc. Our attempt here is to develop prediction-based models using machine learning tools for the early prediction of landslides based on the geotechnical parameters, to take necessary actions to overcome the casualties that will be caused by the impending catastrophe. So, why prediction of these events are more important these days? Predicting the disaster can be very helpful to prepare to evade from the consequences of these catastrophe. However, no one can stop them. We can reduce its effect up to an extent to save our precious lives. Let's get straight to the work. The above illustration is the block diagram of the entire system. The system has both hardware and the software. Let's begin with the hardware. The figure illustrates a working model of the hardware device which we have developed for measuring the environmental changes. It has a set of sensors which tracks the changes in environmental parameters. The parameters include soil moisture, rainfall, ground movement and slope. The interfacing is done through Raspberry Pi. The monitoring can be done in a distance through IoT. The system will observe the stability of the soil in a timely fashion to determine the chance of slope failure. The prediction is acquired by building an SVM-based predictive model. Using historical datasets collected from different sources, the machine learning-based model is trained to predict the slope failure. The model will predict the probability of landslide according to the provided input. Also, the system will sense the movement of soil mass through the slope during the initiation of landslide as an early detection. If there are any casualties detected, the system will send alert notifications to the concerned authorities with the information regarding the location and severity of landslide. The picture here shown is the graphical user interface we have developed to interact with device. It is developed by USANPy Qt5 package in Python. The historical data we collected had many missing values. As a pre-processing stage, we have imputed the missing values by expectation maximization technique. The dataset is imbalanced. It will have a tendency towards the majority class on prediction. To solve this problem we have used several sampling techniques and thus we obtained a balanced dataset. For real-time prediction, some geotechnical parameters like cohesion and angle of internal friction of soil cannot be obtained continuously using any sensors. Hence a separate regression model is used for computing these parameters for each samples in real time, and these values are fed to the classification model to obtain the final output. Here are some snaps of code for training models we have built for the prediction. First is SVM classifier and the next is KNN. The model was trained using pre-processed historical datasets. We have obtained a result as shown here. Both SVM and KNN has obtained the accuracy of 97% with precision of 1.0 for case 0 and 0.86 for case 1. Also with recall of 0.96 for case 0 and 1.0 for case 1. Different algorithms were implemented and finally we have opted SVM for its best results. Hence we uses SVM for predicting landslides once the data is obtained from remote locations using the hardware mounted in the place in an optimal way. So we have successfully designed a system for predicting landslide and thus to reduce its consequences. Hope it will be useful in the future for the disaster management. Thank you for your valuable time and support.